Hello everyone, welcome back to Shubhra. In this video, I'll discuss about Adhoc Sensor Networks, which is there in JNTUH 4th year 2nd semester. In this video, I'll discuss about Unit 3 important questions along with the solutions. I have already explained the Unit 4 and 5 important questions along with the solutions. You can go and check out on my channel, the recent uploads. And if you're watching this video for the first time, if you're watching this channel for the first time, then subscribe to it for more videos like this. And if you watch this video till then, for sure, you can easily score 90 plus for sure. And subscribe to Shubhra for more videos like this. Done. Let's get into the video. This is the Unit 3 syllabus of Adhoc Sensor Networks. It is completely about geocasting. Go and check out these two videos. After that, come back to Unit. These are all the questions I have prepared in such a way that it will cover the entire syllabus of this Unit 3. Clear? So that you cannot miss anything. So, anyhow, you can easily score 90 plus. Easily. Let's start from the first question. Explain geocaching in MANETs. MANETs is nothing but mobile ad hoc networks. Discuss its concept, need and how it differs from traditional multicast routing. Here geocasting in MANETs. Geocasting is a communication method in MANETs, which means mobile ad hoc networks, where the data is sent to all nodes within a specific geographic area or a specific region instead of specific node address. Clear? That is geocasting. It is a way of communication in MANETs. The data sent to all nodes just based on the geographic area, not on the specific node address. Clear? This is what the geocasting means. Here it combines the location-based routing with multicast communication, and the geographic region is defined by the sender only, which is called as geocast region. And only nodes inside that region receive the messages. The nodes which are there in that particular region will only receive the messages. It uses GPS or location services to identify the node's position. Clear? How it will send to that particular nodes only means it will use the GPS or the location services that will identify the node positions, so that it can easily send the messages to that particular nodes based on the geographic area. Routing is based on location information instead of node's ID. As I already told you, it doesn't go with the node address, it will go with the geographic area. Working principle. The source node sends packet with the region details. After that, intermediate nodes forward packet towards the target area. After that, when packet reaches to the region, to the particular region, that geographic area, it is broadcasted to all nodes inside, which are there inside the geographic area. Outside nodes ignore the messages. Clear? This is how exactly the geocasting in MANETs will work. Needs for geocasting. What are all the need for these geocasting? Efficient communication in location-specific applications and reduces unnecessary network traffic, saves bandwidth and energy. It is useful in emergency and real-time system. These are all the needs for geocasting. And what are all the applications of this geocasting? Means disaster management. It's sending alerts to affected area. By sending alerts to the affected area, it will manage the disasters. And military operations, region-based community. And traffic management system and location-based services. These are all the applications of this geocasting in MANETs, that is mobile ad hoc networks. Here is the difference between geocasting and traditional multicast routing. If you understood this much, then you can easily write down in your own words. Geocasting is based on the geographic location at a specific place, and traditional multicast routing is based on the group of membership, that is node IDs. And here the targeted nodes, all nodes within a specific region are the targeted nodes. Only selected group members are the targeted nodes. It is group management is not required in the geocasting, and in traditional multicast routing, group management is required for group creation and maintenance. Here location based routing. We use location based routing technique in the geocasting, and tree based or mesh based routing in the traditional multicast routing. Here the overhead is low, no group maintenance. There is no group maintenance, that is why the overhead is low. Here it is high due to the group management. Clear? And the scalability is high in dynamic networks. It is limited due to management overhead. The management overhead is high, that's why it is limited. The scalability is limited. And mobility handling, better suited for high mobility. And here it is difficult to manage with the high mobility. Efficiency, it is efficient for region-based communication, and this one is efficient for fixed group communication. The complexity is less compared to the traditional multicast routing. Here the complexity is more. The example use, which means the applications we use in disaster alert and traffic updates. The traditional multicast routing is used in the video conferencing and group communication. Clear? If you understood this much, you can easily write down in your own words in theoretical format as well, not only in the tabular form. Here the second question is location based multicast, that is LBM, as a data transmission oriented geocasting protocol. We have to explain this one as data transmission oriented geocast protocol. Here and let us understand what is location based multicast. LBM is a data transmission oriented geocasting protocol used in MANETs, which means mobile ad hoc networks. It delivers the message to all nodes within a specific geographic region, which means it is also a geocaching protocol only, because it will deliver the messages within a specific geographic region, which comes under geocaching protocol. And it uses location information for routing, that is GPS. I have already told you that it will use the GPS for location tracking, and no need to create or maintain the routes before transmitting, and data is directly forwarded towards the targeted region only. This is how exactly it is. And working mechanism. Source node defines the geocast region. It will define the geocast region, and packet is forwarded using location based forwarding, which means it will work exactly how exactly the geocaching works, and nodes decide to forward based on their positions. Based on their positions, it will forward the message, and when packet reaches the region, after reaching the packets to the region, it is broadcasted to all nodes inside. Clear? In that region only. Forwarding strategies in LBM. What are all the forwarding strategies? Flooding based LBM, which means packets are flooded into the forwarding zone, and all nodes in the zone retransmit the packet again. And simple but causes high redundancy and overhead. It is simple but it will causes the high redundancy and overhead as well. And the second one is directional forward, which means restricted flooding. Here only nodes in a specific direction forward the packet, and it reduces the unnecessary transmission. It improves the efficiency and compared to full flooding. Clear? The advantages are no route discovery needed. No need to discover the route here, and simple and easy to implement. It is suitable for highly dynamic network, and it reduces the delay in the transmission, data transmission. The limitations of location based multicast are flooding causes high overhead, as I already told you here. It causes the high overhead here. It causes the high overhead and redundancy. And after that, possible packet duplication and not energy efficient in dense networks, and it requires the accurate location information, or else it will not send the packets to that particular location. The applications wherein all we use this means in emergency message delivery, traffic information system, military communication, and location based services. We use this one, this location based multicast. In simple words, location based multicast is an efficient geocasting protocol focused on the fast data delivery, and it works well in dynamic environments but suffers from flooding overhead. This is the biggest disadvantage of this location based multicast. Clear? Let us move to the next question. Explain GeoTORA, which means Geocasting TORA, as a route creation oriented protocol. Discuss the route establishment, maintenance, and its performance in dynamic networks. What is GeoTORA? Here, GeoTORA is a route creation oriented geocasting protocol. Here, as they have told already, TORA means it is temporarily ordered routing algorithm. It creates routes to deliver the data to a specific geographic region in MANETs, which means mobile ad hoc networks. It will create, what it will do means it will create the route to deliver that data to a specific geographic region. If there is no route, then how can it will send the data to that particular region? That's why this plays a major role, important role in the geocasting. The basic idea, it combines location based routing with TORA's link reversal concept. Along with that, it builds the route only when it is needed, on demand. It works only on demand, and it maintains the multiple routes to improve the reliability as well. If this route is not working, it will go with another route. That's why it maintains the multiple routes to improve the reliability. Route establishment, how it will do the route establishment, let us understand. Source node sends a route query, that is QRY, route query towards the geocast region. After that, nodes forward the query based on the location information. After that, when a node inside the region is reached, it sends a reply. Clear? A directed acyclic graph is formed from the source to region after reaching that. After the reply, data packets are then forwarded along this established route. Clear? And how the route is maintained. If a link break due to node mobility, local repair is performed. If there is breakage in the node, then the local repair is performed. After that, it uses link reversal mechanism to re-establish the route. It will re-establish the route by using link reversal mechanism. Only affected nodes are updated their routes. Whatever the nodes they have a breakdown, only the affected nodes update their routes. Clear? After that, it reduces the need for complete route rediscovery. Clear? And performance in dynamic network. How it will perform in dynamic networks? It handles the high mobility efficiency using quick route repair. And it supports the multiple paths, increasing their robustness. It doesn't follow only the one path, single path. It will follow the multiple paths so that it can increase the robustness. And it reduces the control overhead compared to global updates. And it will reduce the overhead, which means the biggest advantage I can say, and which is compared to global updates, and adapts well to the frequent topology changes as well. These are all the advantages also I can say. And the special advantages of this GeoTORA are efficient route creation on demand. It will create the route only on demand efficiently. Fast recovery from link failure. If there is any failure in that particular link, it will recover from that failure immediately. It supports the multiple routes. As I already told you, it will supports the multiple paths, increasing the robustness, and scalable in large and dynamic network as well. Clear? And the limitations are complex algorithm compared to simple protocols. This algorithm is very complex compared to the other protocols, and control message overhead during the route setup. The message overhead, this is the drawback actually, the message overhead, and it requires accurate location information. If I don't have the accurate message location information, I cannot send the packets there to that particular region. That is the limitation. And it performance and the performance may also degrade in very dense networks. These are all the limitations. Overall, in simple words, GeoTORA is suitable for dynamic managed due to its adaptive routing, and it provides the reliable and efficient geocasting through route creation maintenance mechanisms. Clear? Let us move to the next question. Describe mesh-based geocast routing, that is MGR protocol. Explain how mesh structures are formed and maintained along with the benefits and challenges. Here the mesh-based geocast routing, MGR, it is a route creation oriented geocasting protocol that uses the mesh structure to deliver the data to a nodes in a geographic region. Everything which is comes under geographic region only in this unit 3. Here it provides the multiple paths between source and destination region for reliable communication. There are multiple paths between the source and destination for reliable communication and the robustness. Basic idea here, instead of single path, I have told you there are multiple paths. MGR creates a mesh, that is multi-interconnected paths are there. We use the mesh topology here. It ensures the data reaches the region even if some link fails. Even if one link fails in the middle, it will reach the destination properly. That's why we use the mesh topology here, the multiple paths. It improves the robustness in the manets, which improves the robustness. Mesh formation, how it is formed. Source node sends the geocast request towards the target region. It will send a request to the targeted region, and intermediate nodes forward the request to the based on location. Based on the location, it will forward that request. And nodes inside the region respond back to the source. The nodes which are present inside that region, that will respond back to the source. After that, multiple paths are formed between the source and the region. These paths together create a mesh network. These, whatever the paths they are formed from source to destination, that is called as a mesh network. Mesh maintenance. How it is maintained? Let us see. Nodes periodically exchange control messages to maintain connectivity. And if a link breaks, alternate paths in the mesh are used. Even if the failure in one link, it will go through another path to that destination. Local repairs are performed without rebuilding the entire mesh. It won't rebuild the entire mesh even if one path is failure. And mesh is dynamically updated as nodes move. Clear? Let us see how exactly the data transmission will happen. Packets are forwarded through multiple available paths. Packets are forwarded from multiple paths avoided, which are formed like a mesh topology, and it ensures the high probability of successful delivery. Because the multiple paths are there, for sure it will deliver successfully, increase the robustness, and it reduces the packet loss due to node mobility. It reduces the packet loss also because of the node mobility, and the benefits are high reliability due to the multiple paths. Again and again, no need to explain, I think. And robust against link failure and node mobility. The same thing I have explained. Better packet delivery ratio and suitable for highly dynamic networks as well. The challenges, what are all the challenges we face in this means? Higher control overhead to maintain the mesh. And it is increased redundancy, duplicate packets maybe they, that is the biggest challenge, and more energy consumption because this is a mesh topology, multiple paths are there, that's why more energy consumption. Complexity in managing multiple paths, this is also the biggest challenge. In simple words, MGR improves reliability of geocaching using mesh structure, and it is ideal for dynamic managed, but it introduces the overhead and the complexity, which means the challenges. Let us move to the next question. Give an overview of TCP protocol and explain its basic working principle with including connection establishment, congestion control, and reliability. TCP, everyone knows about this. This is transmission control protocol. Here it is a connection oriented transport layer protocol, and it provides the reliable, ordered, and error-free data transmission, which is very flexible as well. The key features are connection-oriented communication and reliable data delivery, flow control and congestion control, error detection and recovery at the early stages, and in-order delivery of data. These are all the key features. And the basic working principles, how exactly it will work. Connection establishment. There are three-way handshake. That is, the step one is sender's synchronization packet. After that, receiver sends the synchronization, along with that an acknowledgement that it has received the synchronization packet, and sender sends the acknowledgement. Again, it has received after receiving the acknowledgement from the receiver, again sender will send back that acknowledgement. You have to represent in a diagrammatic format here. I didn't do that, just represent in a diagrammatic format, this one. Okay, sender one side and receiver, how exactly they are sending and receiving the acknowledge and synchronization packets, everything. After sending the acknowledgement from the sender, the connection is established. Clear? The connection establishment, this is the first step. Data transmission. Data is divided into segments here. Each segment has a sequence number. Receiver sends the acknowledgement for each segment separately. It ensures the correct order of data. Clear? It will send separately the acknowledgement for each segment, which ensures the correct order of the data. And reliability mechanism. It uses the sequence numbers to track the data, and the acknowledgement confirms the delivery. After receiving that, acknowledgement should be sent. After that only, it will confirm the delivery. Lost packets are retransmitted again. If there is any loss, then it will retransmit. And checksum is used for the error detection. We use the checksum for error detection. Duplicate packets are removed. If there is any redundancy, those packets are removed. And flow control, it prevents the receiver overload and uses sliding window techniques. Sender adjusts the speed based on the receiver capacity. Based on the receiver capacity only, sender will adjust the speed. If it is receiving slowly, then it will send it slowly, make it slowly. Congestion control, it controls the traffic to avoid the network congestion. This is how exactly the TCP protocol works. The phases are slow start, which means increases the transmission rate quickly, and congestion avoidance, it increases the rate slowly, and fast retransmit, which means retransmit the lost packets quickly. Fast recovery, maintenance flow after the loss. The connection termination, when the connection should terminate means uses FIN and acknowledgement signals. After sending the acknowledgement signals from the receiver, then it will terminate it. Connection is closed safely. Clear? TCP ensures the reliable and efficient communication. Along with that, it uses multiple mechanisms for stability and performance. Let us move to the next question. Describe the challenges faced by the TCP in managed, such as route failures, node mobility, congestion, misinterpretation, and packet loss. Here the challenges are, they have only told that the route failure, node mobility and all. We have to explain those things. TCP is designed for wide network. Everyone knows that this is a wide network and it performs poorly in managed due to dynamic topology and wireless issues. It has the issues in wireless because it deals with the managed, that is mobile ad hoc networks. Clear? The root failures, they have only told to explain this root failure. The frequent link breakages due to node movement. Due to the node movement, the breakage is in the link. After that, frequently. That's why this is the biggest disadvantage. And TCP assumes packet loss is due to congestion, but it leads to the unnecessary retransmission, and it causes the delay and reduces the throughput. This is how the root failure is the biggest disadvantage. And node mobility. Nodes continuously move, as I already told you, and changing network topology. It will change the network topology and routes become invalid quickly. Frequent route discovery is required. After that, it increases the delay and packet loss as well. This is node mobility. And congestion misinterpretation. TCP treats all packets loss as a congestion, as I already told you. For the congestion only it is happening. In managed, losses may occur due to the mobility or errors also. TCP unnecessarily reduces the transmission rate and results in poor bandwidth utilization. And packet loss. High packet loss due to wireless interface and link errors, and retransmission increase network load. Again and again sending, that increases the network load and it reduces the overall performance as well. And high delay, there is high delay, that is latency, and route discovery and the recovery take more time, which causes the delay and it causes the increased end-to-end delay. It affects the real-time applications as well. Network partitioning. Network may split into disconnected parts and TCP connection may break completely. Okay, and data cannot be delivered until the reconnection. Again the delay. Hidden and exposed terminal problem. Medium causes the collision and hidden nodes lead to the packet loss. And it exposed the nodes reduce the channel utilization. Limited bandwidth. Wireless links have the lower bandwidth and congestion and retransmission worsen the performance. In simple words, TCP faces the multiple challenges in managed due to the mobility and wireless nature. And standard TCP mechanisms are not suitable without modifications. The next question is explain the solution and enhancements for TCP over Adhoc networks, including TCP variants, cross-layer approaches and feedback-based mechanisms. Here, standard TCP is not suitable for managed due to mobility and wireless issues. As I already explained you in the previous question, enhancements are introduced to improve the performance. Enhancements are introduced in this to improve the performance. TCP variants, we have TCP Reno or New Reno. It improves the congestion control and loss recovery as well. It uses the fast retransmit and fast recovery. Still assumes the loss are due to congestion only here also. And TCP SAC. Receiver informs the sender about the loss segments. Only missing packets are transmitted again. It improves the efficiency in high loss environments. TCP Vegas, which means it detects the congestion before packet loss occurs, and it uses the delay based congestion control. It provides the better performance in managed. TCP Westwood, it estimates the available bandwidth and adjusts the congestion window accordingly. It performs better in wireless network. Cross-layer approaches. It is the interaction between transport layer and lower layers. Transport layer and the lower layers. Between these two, there will be an interaction, right? That interaction is called as cross-layer approaches, and TCP gets information from network and EMSC layers. It helps to distinguish between the congestion loss and link failures. The benefits are it avoids the unnecessary reduction in transmission rate and it improves the throughput and efficiency, faster reaction to route failure. And we have three feedback based mechanisms: explicit link failure notification, explicit congestion notification, and acknowledge based feedback. And other enhancement techniques are split TCP and freeze TCP. Split TCP is nothing but it breaks the end-to-end connection into segments and it improves the performance over the unstable links. Freeze TCP means it will pause the TCP during the connection. That is freeze. It avoids the unnecessary transmission. In simple words, TCP performance in managed improves using variants, cross-layer design and feedback mechanisms. These solutions helps to handle the mobility, reduce the packet loss and improve the overall efficiency. Here completes the Unit 3 of Adhoc Sensor Networks. If you found this even 1% helpful, then like this video and share this with your friends. And if you want me to explain any particular subject topic, comment below and let me know. For sure, I'll consider that. And subscribe to Shivpraj World for more videos like this. Join the WhatsApp channel for recent uploads. Thank you very much for watching.